Now, in this lecture, we find out the radius of the circle. The drawing, we have a circle. Inside the circle, we have chord VD that is equal to 2 units. Chord AC equals to square root of 2 units. And this angle DEB equals to 45 degrees. And our mission is to find out the radius of this circle. So we'll use two rules in order to solve the question. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Yeah. Read the rule again. The central angle is twice as big as the peripheral angle resting on the same chord. So here we have central angle AOB that rests on chord AB. We also have this peripheral angle ACB that rests on the same chord AB, and according to the rule is that the central angle AOB equals to 2 times the peripheral angle ACB. Here, angle AOB equals to 2 times angle ACB. This is the first rule, and the second rule is the law of cosines. The law of cosines is true in any triangle. This triangle ABC could be any triangle. The length of side AB equals to A units, side AC equals to B units in its length, the side BC equals to C units in its length, and this angle BAC equals to theta. According to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine theta. So from this equation, it is very easy to arrive to this equation that cosine theta equals to A square plus B square minus C square over 2 times A times B. So here cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay. We define the center of this circle, this point, as point O. We'll join points O and B together by a straight line. We join points O and D together by a straight line. We join points O and A. And finally, we join points O and C. All those line segments are the radii of this circle, because they start from point O that is the center of the circle and ends at any point on the circle. Therefore, they are the radii of the circle. We'll define as the radius of this circle is capital R, so OB equals to capital R. OD equals to capital R, OA equals to capital R, and finally OC equals to capital R. Okay. Now we will focus on chord DB. This angle BAD, repeat again, this angle BAD rests on chord BD, so we'll define the size of angle BAD as x over 2, and therefore the central angle that rests on the same chord DB is BOD. It must be twice as big as the peripheral angle OAB, so it must be equal to x over 2 times 2 is x. In the next step, we will focus on chord AC. So in this chord AC, we have a peripheral angle AOC that rests on chord AC. We define peripheral angle AOC. This angle is y over 2 degrees in size. Therefore, the central angle AOC that rests on the same chord must be equal to twice of the peripheral angle, so it must be equal to y. Okay, so in the next step, we focus on the straight line AB. We have this angle equals to 45 degrees. So the missing angle must be equal to 135 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay. So here in the green triangle AOB, you know that the sum of the angles must be equal to 180 degrees. Triangle AED, the green triangle, the sum of the angles must be equal to 180 degrees. So x over 2, which angles we have in this triangle AED, we have x over 2 plus y over 2 plus this angle, it is equals to 135 degrees. In total, they must be equal to 180 degrees. Repeat again. In the green triangle AED, the sum of the angles must be equal to 180 degrees. So x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We will subtract from this equation 135 degrees. And we get that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees equals to 45 degrees. So we have x over 2 plus y over 2 equals to 45 degrees. We will multiply this equation by 2. X over 2 is x. X over 2 times 2 is x. Y over 2 times 2 is y. And 45 times 2 is 90. We found out that x plus y equals to 90 degrees. We'll subtract x from this equation. And finally we will get that y equals to 90 degrees minus x. Y equals to 90 degrees minus x. In the next step, we will implement the Pythagoras theorem on the pink. We implement the law of cosines in the pink triangle ODB. In the pink triangle ODB, according to the law of cosines, cosine x equals to r squared plus r squared minus db squared, that is actually db equals to 2, therefore it is 2 squared. Minus 2 squared over 2 times r times r. So this equation number 1, is the implementation of the law of cosines on the pink triangle DOB. Cosine x equals to r squared plus r squared minus 2 squared over 2 times r times r. So cosine x equals to r squared plus r squared is 2r squared minus 2 squared is 4, where 2r times r is 2r squared. So cosine x equals to 2r squared over 2r squared minus 4 over 2r squared. cosine x equals to 2r squared over 2r squared is 1. 4 over 2 is 2, so in the numerator we have 2 over r squared. This is actually equation number 1. Cosine x equals to 1 minus 2 over r squared. Okay, this is equation number 1. In the next step, we create equation number 2 by implementing the law of cosines and triangle AOC. Repeat again, we will implement the law of cosines in this yellow triangle, triangle AOC. We get that according to the law of cosines in the yellow triangle, triangle AOC, cosine y equals to r squared plus r squared minus ac is square root of 2, so it is minus square root of 2 square is 2, minus 2 over 2 times r times r. Repeat again. According to the law of cosines in the yellow triangle, triangle AOC, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. Okay, so here, according to equation number 2, cosine y equals to r squared plus r squared is 2r squared minus 2 over 2r times r is 2r squared. So cosine y equals to, we split this expression into two expressions, so it is 2r squared over 2r squared minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared is 1 minus 2 over 2 is 1, so in the numerator we have 1 over r squared. Okay, so we have here two equations. According to equation number 1, cosine x equals to 1 minus 2 over r squared, and according to equation number 2, cosine y equals to 1 minus 1 over r squared. We have already found out that y equals to 90 degrees minus x. So we substitute y this equation number 2 by 90 minus x. Therefore, we will get that cosine y equals to cosine 180 degrees minus x, because y equals to 180 degrees minus x, cosine y equals to 180 degrees minus x. And according to the trigonometric identity that cosine 90 degrees minus theta equals to sinus theta, we get that cosine 90 degrees minus x equals to sinus x. In conclusion, we found out that cosine y equals to sinus x, and according to equation number 2, first of all, cosine y is sinus x, so we will substitute cosine y by sinus x, and according to equation number 1, it equals to, according to equation number 2, this equation number 2, cosine y equals to 1 minus 1 over r squared. 1 minus 1 over r squared. We have equation number 2 that states that sinus x equals to 1 minus 1 over r squared. And according to equation number 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have here two equations, sinus x and cosine x, and we have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. So we use this trigonometric identity in our two equations, sinus x and cosine x. So here we know that sinus x equals to 1. First of all, we substitute 1 over r squared by t, it equals to t according to our definition. Therefore, we get that in equation number 1 we have this, in equation number 2 we have sinus x is equal to 1 minus 1 over r squared is t, so it is 1 minus t, and according to equation number 1 we have cosine x that is equal to 1 minus 2 times 1 over r squared. So it is 1 minus 2, and 1 over r squared is t. So we substitute 1 over r squared by t, and you get that cosine x equals to 1 over minus 2t according to equation number 1, while according to equation number 2 we found out that sinus x equals to 1 minus t. So we implement the trigonometric identity that sine square theta plus cosine square theta equals to 1 in our two expressions. So sinus x equals to 1 over t. Therefore, sinus square x equals to 1. Again, sinus x equals to 1 minus t. Therefore, sinus square x equals to 1 minus t squared plus cosine square x. Cosine x equals to 1 minus 2t. Therefore, cosine square x equals to 1 minus 2t squared. That equals to 1. So this equation 1 minus t squared plus 1 minus 2t squared equals to 1 is the implementation of this trigonometric identity in our two expressions for sinus x and cosine x. We'll open the brackets in this side of equation number 3, and we get that according to equation number 3, one minus t squared equals to 1 plus t squared minus 2t plus 1 minus 2t squared equals to 1 plus 2t squared is 4t squared minus 2 times 2t is minus 4t equals to 1. So actually, this equation, equation number 3, is the equation after we open the brackets in this side of equation number 3 here. Okay. So here we have t squared plus 4t squared is 5t squared. Minus 2t minus 4t is minus 6t. And finally, we have 1 on both sides of the equation, so what 1 will get cancelled. And we left only with 1 here, so it is plus 1 equals to 0. Here we have 0. Minus 60 equals to minus 5t minus 1t. So the substitute minus 60 by minus 5t minus t. So in question number 3 we have 5t squared minus 5t minus t plus 1 equals to 0. In the next step, we'll take out 5t as a common factor from 5t squared and from minus 5t. So 5t is a common factor from those two expressions. So inside the brackets we have what is left from 5t squared after we took from it 5t as a common factor. What is left is actually t, and what is left from minus 5t after we took from it 5t as a common factor, what is left is actually minus 1. In the next step, we take out minus 1 as a common factor from minus t plus 1. So what is left from minus t after we took from it minus 1 as a common factor? What is left is actually t. We will also take out a common factor from 1. So what is left from 1 after we took from it minus 1 as a common factor? What is left is actually minus 1. So we took out minus 1 as a common factor. Here we have, so it is, we have here minus, so we took a common factor of minus 1 for minus t, so inside the brackets we have t, and here we took out a common factor of minus 1, so, and here we have 1, so inside the brackets we left only with minus 1 because minus times minus is plus, and it is equal to 0. In the next step we will take out t minus 1 as a common factor from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually 5t, and what is left from minus 1 times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually minus 1 equals to 0. So here we have two solutions. The first solution is that either t minus 1 equals to 0, and the second solution is that 5t minus 1 equals to 0. So here t minus 1 equals to 0, so t equals to 1. And according to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared in this equation. So and we'll get that 1 over r squared equals to 1. We'll multiply this equation by r squared, and we get that 1 equals to r squared. Here we'll take out the root of from this equation, and we'll get that r equals to either plus 1 or r equals to minus 1. But because of the fact that r is a length, it must be positive, so a positive number, so r equals to minus 1 is not possible. We cancel the solution. We left only if r equals to plus 1. According to the second solution, we have 5t minus 1 equals to 0. We will add to this equation 1, and we will get that 5t equals to 1. We will divide this equation by 5, and we will get that t equals to 1 over 5. T, according to our definition, equals to 1 over r squared, so we substitute t by 1 over r squared in this equation, and we get that 1 over r squared equals to 1 over 5. We'll cross multiply this equation, and we'll get that r squared equals to 5. We take out a root from this equation, and we'll get that we have two solutions possible. R equals to plus square root of 5 units, and then the second solution is that r equals to minus square root of 5 units, but again, because of the fact that r is a length, and the length must be a positive number, r equals to minus 5 squared is not possible, so we cancel the solution. So we left only with r equals to plus square root of 5 units. And the second solution is that r equals to plus 1. Okay, and here in the drawing we have line segment code DB is not the diameter of the circle. Why? Because it doesn't pass through the center of the circle. The center is here, and because of the fact that code DB doesn't pass through the center, it cannot be the diameter. And because of the fact that the diameter of any circle must be longer than any chord. It is the longest chord. So it must be greater than dB. So the diameter 2r must be greater than dB. Repeat again. The diameter of this circle is of course 2r. The diameter is twice as long as the radius, so it is 2r. It must be greater than chord dB, because the diameter of any circle is the longest chord in the circle. So, and dB is not the diameter, so it must be greater than chord dB. And it is given as the equation that dB equals to 2. So we substitute dB by 2 and we get that 2r is greater than 2. We divide this equation by 2. And finally we'll get that r is greater than 1. And because of the fact that r is greater than 1, it cannot be equal, the solution that r equals to 1 is not possible, because r must be greater than 1. So r equals to 1 is not possible. And we're left only with the solution that r equals to the square root of 5 units. That is actually, in terms of numbers, it is 2.236 units. Okay. Again, the solution to this question is that the radius of this circle equals to either square root of 5 units, or in terms of numbers, r, the radius of the circle, equals to 2.236 units. In the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. Okay, we actually used 2 rules in order to find out the radius of this circle. We have actually rule number 1 that states that the central angle is twice as long as the peripheral angle resting on the same chord. We have peripheral angle AOB that rests on chord AB. We have also central angle AOB rests on the same chord called AB. And according to this rule, the peripheral angle is twice as big as the peripheral angle ACB. That is to say, AOB equals to 2 times ACB. Again, AOB equals to 2 times ACB. This is the first rule that you use. And the second rule is the law of cosines. The law of cosines is true in any triangle. So, if this is triangle ABC, that could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, and finally side BC equals to C units in its length. And this angle BAC is theta. So in this triangle ABC, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. It is very easy to arrive from this equation to this equation that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay. So we actually define the center of this circle as O. This is the center of the circle, and we join together points O and B, we join together points O and D, we join together points O and A, and finally we join together points O and C. So those 4 line segments are the radii of the circle. Why? Because they start from the center of the circle, that is to say from point O, and touches the circle at any points A, C, D, and B. And this is exactly the definition of a radius. So they are the radii of the circle, therefore we define the radius as capital R. So CO equals to OB equals to OD equals to OA equals to OC equals to capital R. Okay? Then we focus on this chord called AC. In this chord called AC, we have peripheral angle ADC. This peripheral angle ADC that rests on chord AC equals to y over 2 according to our definition. Therefore, the central angle AOC that rests on the same chord must be twice as big as the peripheral angle y over 2, so it must be equal to y. Then we focused on chord DB. On chord DB, we have this peripheral angle, angle BAD. This peripheral angle BAD equals to over x over 2 according to our definition. Therefore, the central angle that rests on the same chord, chord DB, this angle BOD must be equal twice of x over 2, so it must be equal to x. Okay? Then we focused on the straight line DC at point E. It is given us the question, actually we focused on the straight line AB or chord AB. It is a straight line. In this straight line AB, we focused at point E. This angle equals to 45 degrees according to what is given us the question. Therefore, the missing angle must be equal to 135 degrees according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line AB at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned, rule number 1. So this angle equals to 45 degrees, therefore the missing angle must be equal to 135 degrees. Okay, in order to complete the sum of the angles at the upper side of AB at point E to 180 degrees, this angle must be equal to 135 degrees. So then we focused on the green triangle, triangle AED. On the green triangle, triangle AED, we know that the sum of the angles in any triangle equals to 180 degrees, of course. So which angles we have inside triangle AED? We have this angle that is x over 2, we have this angle that is y over 2, and we have this angle that equals to 135 degrees. So the sum of those 3 angles must be equal to 180 degrees according to the rule that I mentioned. We subtracted 135 degrees from this equation and found out that 180 degrees minus 135 degrees equals to 45 degrees. So x over 2 plus y over 2 equals to 45 degrees. We multiplied this equation by 2 and found out that 45 degrees times 2 is 90 degrees. X over 2 times 2 is x, y over 2 times 2 is y. So in total, we found out that, in conclusion, that x plus y equals to 90 degrees. We subtracted x from this equation and we found out that finally y equals to 90 degrees minus x. Okay? In the next step, we implemented the law of cosines in the pink triangle, triangle DOB. This pink triangle DOB. According to the law of cosines in this pink triangle DOB, cosine x equals to r squared plus r squared minus 2 squared over 2 times r. I'll repeat again, the pink triangle, triangle DOB, cosine x equals to r squared plus r squared minus 2 squared over 2 times r. So here cosine x equals to r squared plus r squared is 2r squared, minus 2 squared is minus 4, 2 times r is 2r squared. Okay? then we separated this expression into two expressions. So therefore cosine x equals to 2r squared minus 2r squared minus 4 over 2r squared. 2r squared over 2r squared is of course 1, and 4 over 2 is 2, so in the denominator we have 2. In the denominator we left with r squared. It is 2 over r squared. So in conclusion, according to equation number 1, we found out that cosine x equals to 1 minus 2 over r squared. Then we focused on the yellow triangle AOC. In the yellow triangle AOC, we implemented the law of cosines. So according to the law of cosines, in the yellow triangle, cosine y equals to r squared plus r squared minus ac squared. AC is square root of 2, so ac squared is square root of 2 squared, that is 2. Okay, so it is r squared plus r squared minus 2 over 2 times r times r. Repeat again, in the yellow triangle AOC, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. R squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. Then we split this expression into two parts. The first part is 2r squared over 2r squared. The second part is minus 2 over 2r squared. Okay, so 2r squared over 2r squared over 2r squared is 1. And minus 2 over 2 is 1. So this expression in total equals to 1 over r squared. So in total we found out that according to the second equation, in the yellow triangle AOC, cosine y equals to 1 minus 1 over r squared. We have already found out that that y equals to 90 degrees over x, so we can substitute y by 90 degrees over x. Okay. So here cosine y equals to cosine 90 degrees minus x, because y equals to 90 degrees minus x. And according to the trigonometric identity that cosine 90 degrees minus theta equals to sinus theta, we get that cosine 90 degrees minus x equals to sinus x. In conclusion, we found out that cosine y equals to sinus x. Therefore, we can substitute cosine y in this equation by sinus x. We did it. Here we can substitute cosine y in this equation number 2, by sinus x. We did it, and we got that according to equation number 2, sinus x equals to 1 minus 1 over r squared. And according to equation number 1, we found out that already that cosine x equals to 1 minus 2 over r squared. Then we defined 1 over r squared as theta. We defined 1 over r squared as t. So we can substitute 1 over r squared in both those two equations by t. 1 over r squared equals to t according to our definition. So we substituted 1 over r squared by t and found out that in equation number 2 we have sinus x equals to 1 minus 1 over r squared is t. So we substituted 1 over r squared by t, so it is 1 minus t according to equation number 2, and according to equation number 1 we actually also substituted 1 over r squared by t, and we got that cosine x equals to 1 minus 2 over r squared. So we have cosine x equals to 1 minus 2, and 1 over r squared is t. So we substituted 1 over r squared by t, and we found out in conclusion that cosine x equals to 1 minus 2t. Okay, then we have the trigonometric identity that sinus squared theta plus cosine squared theta equals to 1, and implemented this trigonometric identity in our two equations. So here we have sinus x equals to 1 over t. Therefore, sinus square x equals to 1 over t squared plus cosine x equals to 1 minus 2t. So cosine square x equals to 1 minus 2t squared. So and according to trigonometric identity, they must be equal to 1. Then we open the brackets on this side of equation number 3, and found out that 1 minus t squared equals to 1 plus t squared minus 2t, and 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t, that is minus 4t, and it is equal to 1. So this is equation number 3 after we open the brackets. Okay. So t squared plus 4t squared is 5t squared, minus 4t minus 2t is minus 6t, and here we have 1 on both sides of the equation, so 1 will get cancelled. Here we have 0, and we have also another one, so it will be plus 1. So in conclusion, according to this equation, equation number 3, we found out that 5t squared minus 6t plus 1 equals to 0. Then we substituted minus 6t by minus 5t minus t here, and found out that 5t squared equals to minus 5t minus t plus 1, that is equal to 0. Then we took out 5t as a common factor from those two expressions. So inside the bracket, so 5t is a common factor, so inside the brackets we left with only t minus 1. Then we took out minus 1 as a common factor from those two expressions, minus t and 1. So inside the brackets we left with t minus 1, that is equal to 0. Then we took out t minus 1 as a common factor from those two expressions. So inside the brackets we left only with 5t minus 1, that is equal to 0. So here we have two solutions that are possible. The first solution is that t minus 1 equals to 0, and the second solution is 5t minus 1 equals to 0. So according to the first solution, t minus 1 equals to 0, so t equals to 1. We defined the, according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation, and found out that, so 1 equals to 1 equals to t, and t is 1 over r squared, so 1 equals to 1 over r squared. We multiplied this equation by r squared and found out that r squared equals to 1. Then we took a root from this equation and found out that r equals to the square root of 1. It has the positive square root of 1, and that is 1, and the negative square root of 1, that is minus 1. But because of the fact that r is a length, it must be a positive number. It cannot be equal to minus 1, so we cancel this solution of minus 1, and we left only with r equals to plus 1 units. Then we have the second solution, that 5t minus 1 equals to 0. So 5t minus 1 equals to 0, it means that 5t equals to 1. We divided this equation by 5 and found out that t equals to 1 over 5. Okay, and according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation and found out that 1 over r squared equals to 1 over 5. Here we cross multiplied this equation and found out that r squared equals to 5. Then we took out a root from this equation and found out that r equals to the square root of 5. So we have r equals to the negative square root of 5. It cannot, r is a length, it cannot be a negative number, so r equals to minus square root of 5 will get cancelled, and we left only with r equals to plus square root of 5. Okay, and then we have here in the drawing, it's very easy to see, chord AC doesn't pass through the center of the circle. Any chord that doesn't pass through the center of the circle cannot be diameter. any diameter must pass through the center of the circle. That is to say 4.0. And because of the fact that AC doesn't pass through the center of the circle, it is not a diameter. AC is not a diameter. And we know that the diameter is the longest chord in a circle. So the diameter 2R must be greater than chord AC. That is not diameter. Repeat again, the diameter, we actually focused, what I said is true, but we focused on chord dB. The same explanation is true about chord dB. dB doesn't pass through the center of the circle, that is to say from 4.0, that is to say it cannot be diameter because it doesn't pass through the center 4.0, and therefore because of the fact that the diameter of any circle is the longest chord, therefore the diameter 2R must be greater than 2B. Repeat again, the diameter 2R must be greater than dB. So dB equals to 2, so we substitute dB by 2 and found out that 2R is greater than 2. Okay, we divided this equation by 2. So here 2 over 2 is 1, so R is greater than 1. We found out that R is greater than 1. If R is greater than 1, it cannot be equal 1. So we cancel this solution and we left only with the second solution, that R equals to square root of 5 units. So in terms of numbers, it is 2.236 units. Repeat again, the diameter of this circle capital R equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.